بسم الله الرحمن الرحيم والحمد لله والصلاة والسلام على أشرف خلق الله. Today, inshallah, we will continue the section 2 of the practical and continue talking about the thermal red eye. So here, this is the display, and it is a display screen where the count per second, as we said in the last presentation, or it display the dose rate also, as well as other information such as the battery status and like that. And this here is the alarm lights. So it will blinking red light will show that the level of radiation has risen above the alarm level, and the bottom and the menu, this is for main operations, include main menu, menu bottom, which give the options such as switch off, sound on off, or light on off, and like that. Behind the this detector, it is the sensor area, where this is the position of the crystal in the back of the detector. Okay, the IA requirement for PRD set a requirement which make sure that equipment is suited to condition you could be working in and ways you need to use the instruments so they are reliable and trustworthy. This includes simple to operate, small and light, durable and weather resistance, battery operated with a more than 400-hour battery life, base alarm level set against the count rate, secondary safety alarm that sound as a warning when the dose rate reach predetermined level, display that can switch between count per second and the dose rate, temperature range between -20 and +50 Celsius. 3 alarm indicator, light, sound, and vibration. So all this is the requirement of the IA for PRDs. To check your knowledge, read this question. In which of these situations would you use the PRD? Please read all of them. I will select one randomly. It may be wrong or right. Okay, randomly again. Okay. Maybe you can see the correct answer now. And let's shift now for radionuclide identification device. Once the radioactive source has been detected and localized, the next step is to find out what type of radioactive material you have detected by identifying the isotopes. This can be done using a radionuclide identification devices, and these instruments like PRD are able to detect and localize radiation. However, they have to add the ability to identify radioisotopes. This is one sample of these detectors that can identify the isotopes. We denote it by RIDS, R-I-D-S. This instrument is able to integral part of your detection capability to identify material once radiation has been detected. What can RID do? RID can be used as a research tool for locating a radiation source by measuring and displacing the count per second rate as it raises and emitted an alarm when radiation reaches a high enough level. And what can RID do also? Identify radioactive isotopes. Okay. And this is the component of RID. Here, exactly ICX Identifier Ultra. This is the name of the device, okay? The display in the middle of the device, its display screen, which display the dose rate indicator or count per second, or the isotopes identification results. The button L or other button M or R. This is the main operation button, which give you options such as switch on, off, and the ability to switch between the finder mode, identifying mode, and dose rate mode. And here, this is alarm. We have two alarms. The ICX Identifier Ultra has a separate alarm light for gamma radiation and neutron radiation. The device can also emit an alarm using sound, vibration, or all three. There are two alarm lights, a red light for a gamma radiation and a blue light for a neutron radiation. In the above of the instrument here, we have the sensor area. This is the position of IC Identifier Ultra crystal, which is the most sensitive area to radiation. Okay, this is another type of same device of red. It is a SPECT MKC A03. And the display here, same again, it will display the dose rate indication and count per second or isotopes identification. And under screening here, you have the buttons, which is the main operation button, and give you options such as switch on, off, sound on, off, and the ability to switch between search mode and identifying mode. And in the above of the screen here, we have the alarm light. So alarm light for gamma radiation and neutron radiation, as well as distinctive alarm sound. There are two alarm, a red light for gamma radiation and blue light for neutron radiation. And the sensor area, it is below here, sensor area with the, the sensor area that make this most sensitive area to radiation. So when we use the detector to identify the material, make sure that the part is positioning at the source. So the detector will give you a guidance on the screen about whether it needs you to move closer to radioactive material for a better reading, or if you are too close and should back away. And we have here a quiz. You have to read the question and to select the answer. I am not going to read it. You have to read it by your own. Okay, it could be right or wrong. I don't know. IA requirement for red is the ability to detect both gamma and neutron radiation, automatic easy mode with the dose rate search and identify capability. Password protected for advanced mode, can be used with a one hand, less than 3 kilometers, more than 8-hour battery life, rugged design for outdoor use, can work in temperature ranging between -20 and plus 50 Celsius, has a microprocessor to store data and use supported software. Even could link also to PC to transfer data. Regarding the detection of neutron radiation, as mentioned earlier in this course, neutron radiation is very hazardous for human body. Some of the pieces of equipment we have covered have the ability to detect for neutron as well as gamma radiation, such as two reds, which have separate alarm light for each. If there is a neutron alarm from one of your pieces of equipment, you should seek assistance from expert immediately and isolate and secure the area. The expert would use another type of instrument, a neutron surge detector, or what we call donated by NSD that is designed to detect as well as localize neutron source. So factor influence detection, the activity and energy, the physical properties of radioactivity material itself will influence whether or not your instrument detects radiation. Another factor is the distance from the source. So the farther away from the source, the lower the level of radiation, and therefore the less likely you are detected. The shielding is another important factor that can affect your ability to detect the radiation. Radioactive material being shipped legitimately will most likely be in a source holder to shield the radiation. Another consideration is that radioactive material being carried in a freight container or official could be shielded by metal element of the container or vessel itself. The speed that the person or vessel pass through your detection area can affect the probability of detecting radioactive material that may be present. Masking situation. Sometimes people to try to defeat the detector and use a legitimate situation to mask the radioactive material that they are illegitimately carrying. For example, they are trying to hide radioactive source in the shipment of granite stones, which are naturally occurring radioactive material. False alarm. Your instrument may give alarm which do not seem have any relation to measurable rays in radiation. These are false alarm, which may be caused by small or natural fluctuations in the background radiation or sudden large movements such as a being dropping. If false alarm occur frequently, have the instrument checked by the expert. Don't let it make you pay less attention to alarm from your equipment. Each alarm could signify that radioactive material is being smuggled, and it is up to you to stop it. Okay, this is here comparison between a detector gamma, detector neutron, localized gamma, localized neutron, identify isotope, safety alarm. And this is the detector here. We have RPM and the PRD, red and nest. And you can see here what could able to detect of this detector for a gamma, or what get able to detect neutron or localize or identify isotope. So you can read this table. So even you can read these notes here about red, all right? And what about the very limited or very limited here for NSD? This is for safety alarm. Check your knowledge. We are nearly at the end of module 3 now. We are covering a lot of information to reduce you to the type of equipment you will find yourself using. So let's see how much you are learning with a few questions to test your knowledge. And I will go through this question, but I'm not going to select the correct answer. It will be like homework for you, and you need to check your knowledge again in the software. I'm not going even to read the question. I will put just a random selection, okay? So now we are reaching the end of module 3, which introduction to radiation detection equipment. In this module, we have covered the main component and function of each device, the IA requirement for the equipment, and the basic on how, when, and where each or one of these equipment should be used. Now we completed 1, 2, 3, and let's jump to section 4. Okay, I will start by introduction to Polymaster BM1703 PRD. Now let's see how to operate the Polymaster model of PRD. First, you can have you go and at using instrument yourself in practical simulation, you can then recap what you have learned by watching animated demonstration. We are going to see how to run instruments on, set up for use, what will happen when detect radiation, and how to apply the source, how to changing the alarm indication setting, and how to switch off the device. Okay, so here we have the mode button in the above and below it the light button. These are buttons which you will use to operate the Polymaster BM1703M. In the simulation, you can use the button, okay? In the simulation, you can use the button by selecting them in the image of the instrument. Let's jump to it. Okay, so I am here. The Polymaster is off now. First, let's switch the Polymaster on. So what we are going to do this, we have to press and hold mode button until the screen display change. And I'm going to do this now. So the device now is starting on. And we'll test the screen's function and battery, then begin to do a background calibration, measuring the background rotation level and setting alarm level accordingly. Now, this is the reading, okay? It's 004 second minus one, okay? And let's now continue. Now the detector is fully operational and ready to use. And a function of Polymaster is the light that illuminate the screen. You will find this useful when walking in a dark area or at night. So you can press the light button to illuminate the screen. So you can see now the screen illuminated again. So it will not work again. I don't know why, but it is okay from the first time. Okay, switching modes. The detector, the Polymaster detectors, measure radiation level in a two-way. It could be a count per second, S-1, or you can use the dose rate indication in a microsievert. And when searching for PRD, it's better to use a count per second because this type of measurements reflect the change in the detected radiation faster than microsievert per hour. Although you should use a microsievert per hour as more of a safety check features. The normal measurements showing the count per second to switch between the two modes, simply press the mode button. So it was changed now. It is 0.06 microsieverts per hour. Background calibration, if you move into different area, sometimes the background radiation level can change. Redoing the background calibration, adjust the instrument to the new background measurement and set a new, more suitable alarm level. To redo the background calibration, you should first press and hold the mode button until calibration appears green. So we will try pressing the mode button until calibration screen appears. Yes. Now you have reached the calibration option. You should reach the mode button to begin the background calibration. In this simulation, you need to press the mode button again to demonstrate this. Move to the next screen to see what's happening when the polymaster is near radioactive source. So if you're farther away, this will be the reading. As you begin to move closer to the radioactive source in the cardboard box, the count per second increase, indicating that more radiation is being detected. So let's jump to close here. You can see how it's changed near the source, and even you can see the alarm detectors here. Switch off the ADU. The polymaster alarm can be in 3 different forms: light, sound, and vibration. The light alarm is always on, but it's possible to switch the ADU and on all the vibration of is if you need to. For example, you may be working covering and don't want any of your equipment to be heard. To switch off the ADU first, the first step is to press and hold the mode button near the menu. Now press light button to change the ADU setting. If your ADU is currently on, this action will switch it off, whereas if it is already off, the ADU will then be turned on. Switch on of the calibration, press mode button. And the VIBR appear, select light button to confirm that you would like to change the vibration setting. After you have done this, you could either press mode once more to return to count per second. To turn the instrument off, you should press and hold down light button until display change to switch off. That's all. In this practical simulation, you just need to click on the light button, but when you're using your equipment, remember that you need to press and hold the light button. Move on to the next page to recap what you have learned about Polymaster PM1703 by watching an animation demonstration. Turning on the device and get it ready to use. Let's look at switching the device on. You can select this link to see how. Maybe you can see now. Okay, all the step we go through it. That's all. I will come back to my screen again. Detection radiation and radiation alarm. It's written also in the PDF, the same step we already mentioned before. So you don't need to go to this link. In the video, I'm not going to open in all of these links, but maybe when you're working with the training in the website of the IA, maybe you can open this link and to read all the steps as you want. Back calibration, again, the summary in this link, changing the alarm setting again in this link, switching the detector off or on again in this link. So let's see what you can remember. Read the question and answer, put your answer here. I will check this randomly. It could be right, wrong. Again, right, wrong, I'm not sure. I will go quickly here. Will be like a quiz and a check of your knowledge. Polymaster PM1703 PRD summary. You should know now how to switch the instrument on and off, set up an instrument, make any change to the function, how to detect for and locate radioactive material. Introduction now to thermal rate I. You can recap what you learned by watching any main demonstration. So we have in the top here the upper bottom, this arrow or bottom and bottom menu bottom on bottom loud speak buttons. So first we need to switch the PRD on. To do this, you should press and hold down, bottom, on, down, bottom, on. I'm going to press it now. And now the screen start. Once you have done this, you will display information include software version and battery status and test alarm indicator. Then it will begin to do background calibration, measuring the background radiation and setting the alarm level accordingly. Now the device is fully operational and ready to use. This is the count per second, CPS, measurement screen, which show the measured radiation level as well as the alarm setting. A handy function of the thermal-rad eye is the light that illuminates the screen. You will find this useful when you walk in a dark area or at the night. Just press the loudspeaker button. You can see the change of the illumination of the screen. It will illuminate the screen. Your device measurement radiation level that surround it in two ways. The first is a count per second, and you can use the dose rate indication in microsievert per hour. For your job, it is better to use a count per second detector and locate radiation because this type of measurement reflects any change in the detected radiation faster than microsievert per hour. Okay. You can press info button to switch from count per second to microsievert per hour. And now it was changed from count per second to the dose rate mode to microsievert per hour. Okay, as well as detecting radiation and offering your high level of radiation through alarm, your thermal radii can also use to locate the source of radiation by using search tune, which you may recognize as a classical sound made by Geiger counter, a different type of radiation detector. So press loudspeaker button or rubber button. You can just pause the animation and select continue to move forward. Let's now move to the next screen to see what's happened when your thermal radii is near radioactive source. Again, if you are further away, the screen show us it's 12 count per second. When you move closer to the radioactive source, it is increased the count per second to 138. And the alarm here start appearing when near to the source. The count per second reach 140,000. Sorry, 14,000 count per second. Okay, so now that you have practiced using the thermal radii while it's alarming and screening, how to search tool will help you to locate the source of the radiation. It will be useful to have a go at making some change to the alarm indicator in your PRD. Press the menu and button to open the screen display the change that you can make. Now that you have entered the menu, you will see that there are several options indicating switching the device off and changing the sound and light setting. Let's try to turn off the sound. So the action along the bottom of the screen are controlling by functions that are positioning above. Switch off is currently highlighted. So to move up on option to reach sound, press the info button. So press info button, which is also marked on an arrow. Now let's continue. Now the sound option is highlighted since off action is located above the menu button. Press this once to change the sound select. So we have seen how to change alarm indicator setting in the menu. This is same process can be used to change other settings in the menu, such as the LED light. Another option that you have for the alarm indicator is to use the headphone or earphone, so that although you still have the sound on, it can only be heard by you. The socket for the headphone is located at the base of the device. Let's press the loudspeaker. And now let's continue. Another useful information is the information and statistics screen, which you can access by pressing info button. This screen shows you the menu and average count per second that have been detected in this session, the maximum count per second that has been detected, and the time that the device has been switching on for. Next, use the mean per max option at the bottom of the dose rate indication screen to enter the statistics screen. When you have finished viewing this statistic, there is an option to reset all at 0 count per second, so you can let the device calculate a new set of a mean per max information. To use the reset option, press the menu button. Once you have finishing using statistics screen, you can use the exit option. Let's press info here. Press on button. So keypad is now locked and secure, but it will still detect radiation and show change the count per second measurement on the screen. If you press any of the button, diagram will appear explaining which button you need to press and in what order to unlock the keypad again. So let's press any button. Now we are going to confirm that you should want switch device off, press menu, and then continue while switch it off. This is a summarization again, how determining the thermorad, detecting radiation and radiation alarm, and information function, changing alarm setting, and switching the device off. All this information are summarized within PDF link here. Let's see what you can remember. This like a quiz. I'm not going to read the quiz for you. You have to read the question. I will select random answer. Okay. Thermorad. This is again question. Okay, here our summary. Let's now jump to ICX identifier ultra-red. You can start to operate ICX identifier rate. First, you can have go at using a experiment yourself in a practical simulation. You can recap what you have learned by watching animated demonstration. Okay, here we have LMR button. The L button will activate the command that's listed in the bottom left and screen. In this case, it will switch the device to finder mode. While M button will activate a command that it is listed in the bottom middle of the screen, the R button will activate the command that is listed in the bottom right of the screen. First, to switch ICX identifier ultra on, press the red power button. Let's press. Now the device is fully operational and show the dose rate mode. To go to the search mode, press L button, which correspond with the finder command. So this is IC identifier ultra search mode screen, where you can use the useful visual display to help locate the radioactive source. When you have finishing using this mode, you can either return to the dose rate mode screen by pressing L button, or you can move to straight on identification mode. So let's press M, which correspond to command ident. Nikolai listed K, potassium 40. While the device is measuring gamma radiation emitted by a source, you may see an instruction on screening asking you to move to the unit close to or farther away from a source. When it has finished, it will show the screen display the identification result. There is a confidence rating represented by first value or of less than or equal to 10, 10 being the most confident. It's now 5. If it is low, if it is low, you may wish to ask the device to add another minute of measurement so that the result is more certain. To do this, press L button. We'll repeat it again. And now, when it's finished, it will show this screen displaying the identification result. When you have a more certain identification result, you may want to save the measurement data or a spectrum. To do this, press M. Here you have to choose between saving the result as the new spectrum at the suggested number. Now, press L to confirm that you would like to save this result as a new spectrum. After saving spectrum, the screen returns to the search mode. Remember, if you have access to the right equipment, you will transfer spectrum to the PC for a further analysis using a USB cable and the ICX Identify Ultra software. The only remaining mode that we have not yet looked at is the advanced mode. If you are in the dose rate mode, this is controlled by the option command, for which you would press R and then select advanced mode. Finally, switching off the device, simply press the red button, power button, until the screen changes. Now it's powered off. Okay. Now let's move to the next screen to recap what you have learned about ICX Identifier Ultra. You can go through all of this summarization. You can just press the link here. It will open for you the PDF to summarize what we learned before. Here we need to check your knowledge. Please read the question and select the right answer. I will select a random one. It could be right or could be wrong. Just to make the video short, I'm not going to read all these questions. This is our summary for red. Introduction to aspect MKCA03 red. Let's see how to operate aspect MKCA03. First, you can have a go to using an experiment yourself in a practical simulation. You can then recap what you learned by watching an image demonstration. Okay, we have here far left bottom, left hand bottom, and black bottom in the middle, and right hand and far right bottom. So the far left bottom will activate the command that is listed in the bottom for left of the screen. In this case, the command is start ident. Left handle bottom will activate the command that is listed on a screen directly above it. The black bottom in the middle will activate the command that is listed in the bottom middle of the screen. A right hand button will activate the command that is listed on the screen directly above it. The far right bottom will activate the command that is listed in the bottom far right of the screen. In this case, the command is the menu. So to switch your screen on, just press the black button in the middle. Now let's press continue. This is a search dose rate screen where you can monitor gamma and neutron radiation level in relation to the alarm level. It all allow you to localize the radioactive material by following indication using by a peak on the graph and change in frequency, put the instrument in Carl change and stabilize. It will display not ready and then ready when the system is ready for use. The startup that it is automatically done if you place the switch of instrument into the kernel. Before you search source, perform background update by calibrated again. This is done automatically by removing the system from Cradle or by pressing the back button when MKC is searching or dose rate mode. Of course, if you press the wrong button, he will correct you. So you can practice this by yourself and read all information displayed in front of you. Again, here is a summary, and this is a summary. Have a link here. You can press the PDF linking until you come to the switching of the device. Finally, we need to check your knowledge. Read this question and select the correct answer. I will select a random answer. Could be right, could be wrong. And let's go back to the main menu. We finish now from 4, 3, 2, 1, and we only have the last session, verification of alarm and confirmation of incidents to complete the main menu. We don't need to go in our course in a scenario 1 and a scenario 2. If you would like to do this, you can do it at home. And after this, it's important to go to the assessment to check your knowledge. Did you know or not? So, welcome to the model 5, the verification of alarm and confirmation of incident. We have 31 slides in this section or in this module. And in this module, we will look at the procedure involved in carrying out radiation detection in your role as a frontline officer. As a fellow, to do this, we will cover the different type of alarms, such as the real, innocent, or false, identifying how to respond to alarm from your equipment, or when your expert support is necessary, and the 3 factors that tell you when incident is a potentially hazard, the importance of documenting the process, safety principles such as verifying the dose rate indication. So your role, detect. The role of FLO, the frontline officer in radiation detection, in case to detect presence of radiation. As we have seen, for this, you could be using a RBM or PRD. Localize, the rule of localize. Once you have detected raised radiation level, you need to locate the radioactive source. To do this, you can use the change in the alarm indicator on your PRD, or you can use RID in assertion. And rule number 3, identify the located radioactive material. This is the main function of RID. It indicates the isotope's presence and categorize the typical materials. So far, we have seen how to perform all these tasks using your equipment. Now let's see how they fit into procedure you should follow as a result of an alarm. Response objective. Whenever the situation, the 3 main response objectives are to minimize any potential health hazard, to bring radioactive material under appropriate control, to investigate, gather evidence, and prosecute any offenders. Response procedure plan. Now we will look at the procedure for responding to the radiation detection alarm. Of course, the action you should take will be set by the specific circumstance of the situation, but here we will look at what you should try to achieve. Let's begin with a summary of the response procedure. Detection of radiation. Please read. Maybe you need to pause the video for a moment to read this information. Verification, separation, screening, and step number 5, localization. You need to locate the source of the radiation. Identification. You need to identify a specific isotope to give you more information. Decision point. Using the identification information and any other information available to you, you now need to make a decision about the situation and what action to take. Here, a quiz. I will select a random answer. Please, you can read this later. Reactivate responses necessary in case of the following. If the alarm from detection screen, random disclosure, discrepancy in a custom declaration or support documents. Proactive response is necessary in the case of intelligence-based report or notification about discovery of non-compliance with transport regulation. Response, so an alarm from your detector is not the only detector that you should respond to. Use your skill and intentions as you would in other area of your role as an FLO and apply them to situations that could involve the illicit trafficking of radioactive material. So this is a summary again. Please read what's written here. Can the radioactive source harm people? There are three things to look for in making sure a situation is not hazardous. That the dose rate is below 100 microsievert at a distance of 1 meter. And there are no neutron detects, and there is no visible contamination such as a leak or spill. So the third question you should ask yourself to determine how you will respond to the alarm. Is this in consent or non-in-consent alarm? The answer to this question will be found in information such as identification result and transport documents. Verification. Now you are going to look in more detail in each stage of response process. So this flow diagram show all of the action and processes that could take place in your response procedure. It looks complicated, but we are going to walk through and explain what you need to do at each stage. First, let's focus on verification stage here with the orange color. You will experience a radiation alarm on routing basing. The first step to make is vary whether the alarm is genuine by using equipment to scan individual or visual second time. Check your knowledge. I will select random answer. False alarm. False alarm can be activated by an instrument, but can be confirmed by independent radiation measurements. Some causes are effect of an instrument, electronic, normal fluctuations of the background radiation, perhaps due to norm and certain building material, mechanical shock, such as equipment being dropped nearby radio frequency interference. Access the hazard and locate source. Let's move on to the next stage in this process where we assess the hazard and locate the source. So remember, it is unsafe if the dose rate reach more than 100 microsievert per hour when you are approximately 1 meter away from the object. So once the presence of radiation has been verified, make sure that you are not putting yourself in a hazard situation by approaching the material. While you are locating radioactive source or at any stage in response procedure, look for a hazard sign. Hazard sign include more than 100 microsieverts at one distance of 1 meter from the object. The second sign is a neutron are detected. The third sign, the visible contamination, such as a leakage liquid or powdery residue. Locating the source. Once the alarm has been verified and you have determined that it is the safe to procedure, you will need to locate the source of radiation. To do this, you use your handle PRD or your red in search mode and use the change in alarm indicators as you get closer to radiation to locate the source, being by separating the individual from their visual or luggage, so you can search each separately to find more precise location. If you locate the material in the first case, for example, it gave idea to search remaining molecules and individual in case that there is a more than one source of radiation. Move away before you begin to search because some detectors require an update by background level first. If you are too close to the material when you're starting to search, the raised level will be registered as the normal background, making it difficult to detect and locate the source. Next, move slowly toward the suspected location, monitoring change in CPS and alarm indicator. Bear in mind that term searching means using your detection equipment to narrow down the location of radiation so that you can use red to identify it. This does not mean manual searching through bag, retrieve the material once you have found out where it is. At this point, you will have no idea what the source of radiation is. How strong is it? Whereas you could be contaminated by it. Or so you could be putting yourself in very hazardous situation by having a contact with the source. Activate safety procedure. So this is the final one. Let's look at the activate safety procedure stage. If at any stage in the process you think the situation has become hazardous, particularly when first checking the dose rate indication when located the source, your safety procedure should be activated. Safety procedure. Let's look again at the three elements of searching hazard situation. The first safety procedure until the official radiological assessment has been made by an expert and then have taken control, you should follow your usual general safety procedure. Isolation of radioactive material is the second key element to dealing with the hazard situation. Notification, the final key element is notify relevant local and national authority who will send expert support to deal with the situation. Check your knowledge. I will go randomly here. Okay, and finally, this is a summary to minimize external radiation. Please read this information, avoiding internal contamination. Please avoid internal contamination by inhalation, ingestion, or absorption. Don't touch or disrupt any material which have leaked or spilled from a suspicious container. Don't eat, drink, or smoke within controlled area. Check your knowledge again. So location process. If after having gone through this process, you locate the source of radiation within notifying or hazardous science, you should go to the next stage, identification. Remember to record what you find at every stage in the response process. We will look at what you should do if the situation is hazard later in this month. Identification, the next stage to look is identification. Identification and categorization. Identifying the source using red give you specific radioisotopes, example cesium-137, which you can compare to the state material on transport document. You will also be given a category which will give you determine whether you are dealing with a natural occurring radioactive material, non-medical isotopes in individual, a legitimate source using an industry or in abnormal situation. If the category is medical, industrial, sorry, natural or no, and the document and other custom declaration appear to be in order, you would class the incident as an inconsent alarm. If it is categorized as a nuclear or a special, or if the document don't match with the identification result, this suggests an abnormal situation and non-inconsent alarm. Okay, so as we have just seen, an inconsent alarm when EPON identification radioactive source, it proved to be legitimate shipment, not a leaked trafficking incident. A radiation alarm caused by radioactive material that is now identified to be used in malicious acts. Here, this is an example situation which might cause an innocent alarm, and there are several material which contain radioactive material that you are likely to come across and which could cause this alarm. This could be natural rock and stone, ceramic. You should be aware to those involved in criminal or terrorist activity may try to test security at a border crossing by deliberating certain alarm to test the capability of the equipment and procedure. Reacting to the non-inconsent alarm once you have determined the situation. The first step, you should be contacted by an expert or for support. That complete the response procedure that you should follow in the event of radiation alarm. As I mentioned it before, you may not need to follow some or most of it, as it may become clearer early on that it is false or inconsent alarm. If at any stage you spot hazard signs, or if you confirm an inconsent alarm, you should call for an expert assistance. Final point, some important points such as the following. Until complete radiological assessment is made, take precautions to avoid contact with radioactive material and follow the general protective guideline. Investigate and consider the incident as a crime and follow the rule for dealing with evidence. You may decide to remove the source for radiation from a bag or visual after having identifying it as being safe to do so, or having received instruction from an expert. Once you have safe to isolate the material, a good idea to research the bank or official you would require to make sure that is not a second source located in the same places, perhaps being internationally masked by the first. Knowledge of check, I will select random answer. Knowledge of check, I will select random answer. Okay, this is the summary of module 5. The different type we cover here in this module, different type of alarm, such as a real, inconsent, and a false. Identification, how respond to alarm from your equipment, the different stage of the response procedure, why it is important to document details of the procedure, and example log sheet to use when you should call for an expert support. With this, we've completed all module 1 and 2, 3, 4, 5, and we will stop here to ending our video. Hope Success for all of you.